Now in this video we'll be looking at the various data types, fundamental data types in C++, and the how to declare variables and how to initialize them. Now before I continue with this video, I would like to tell you guys some things that I made changes to. Now you can see over here I wrote a comment. This is the general the outline of this video, so I would be using this outline as we move on. Now I made changes to my shortcut. Right now, if I need to run the program, I'll have to click over here. But then I needed a shortcut that would make it possible to just use the keyboard. So what I did was I went to settings and then to editor and then to shortcuts, keyboard shortcuts, and then you click on this plus sign on the build. That's where I want to change my shortcut. It's on the build, and then the build is specifically build and run, and then I changed it to shift B. It was I think F9, but I didn't want to use that one. So you can come over here if you want to change it to whatever you want. You can say Control D, and if that shortcut has been taken already, it would appear here something it has been taken or something. But over here it's not been assigned to anything yet, so you can see this none button here. So I'll just after that, if you want this one, you can just click on the add, and you can then you click on add, then OK, and you can then use Control plus D anytime you want to build and run your program. But I prefer shift B. Go ahead and cancel this. If you want to change it, you can follow that procedure. Another thing I want to tell you guys is that I changed the setting general overview of this program, of this setup for this comprehensive tutorials. Now you can see over here there is this main.cpp file, and that's the first file that was created. For you guys right now, I would just advise that you continue using the first file that was created. Yeah, so you'll be writing every code that I'll be writing in here in your main.cpp file. Right now, I don't want to tell you guys about how I set up this environment because it's quite confusing. You have to use some functions which you have not learned right now. And as a beginner, it will be frustrating to kind of go through this. So just write your code in this one, int main function of your main.cpp file. And later on, when we get to learn functions, I'll then tell you guys how to set up this environment. So that was the second thing I wanted to tell you guys. Now the third thing is that I changed the color of the output. So let's run this. Shift B is my shortcut, and this is the output. So anytime it outputs, it would be on a black background with green text. This is how I made changes to that. If you want to make changes to that as well, you can just use this line of code, system color A0A, to make these changes to your code. There is a ton of combinations for color changes which you can access from command prompt. I'll just do I don't know if I should do that right now. Okay, so let's just get to the business of the day. So the fundamental data types in C++. The first one is what we call character types and is denoted by CHAR. Examples are, you can have this, and they are always in single quotation marks. So you can have E is a character. You can also have A is a character. You can also have let's say 6. It's a character. Anything that's stored in single quotation marks is a character, right? So that's what characters are. Now we have numerical. The second types are numerical integer types, and they are denoted by int. And these numbers can't be decimal, so they are non-decimal, they are non-fractional, and they are non-exponential. They are whole numbers and can be negative. An example is we can have whole number like 6, you can have whole number like 7, you can have whole number like 9. Yeah, these are integers, and we can have -4 as well, right? So these are what we call integers. Now The third type is floating point types, and it's denoted in C++ by float, the keyword float. And these numbers are decimal numbers, and they can be exponential and they can be negative. Yeah, examples are, so we have an example like 8.05, it's a float. We can also have negative 4.5, 4.6, it's a float. And we can also have an exponential like 7e4. And this simply means, in basic terms, it means 7 times, so 7 times 10 to the power 4. That's what it means. So 7e4 means 7 times 10 to the power 4. You can also have an example like 5.6e negative 6. And this simply means, in basic terms, 5.6 times 10 to the power negative 6. Yeah, so that's what it means. And these are all floating point types. The fourth type is Boolean types, and these can only be true or false. They only store two values. So you can have a Boolean value which is true and which is equal to 1 in programming, and you can have a Boolean type of false and which is equal to 0 in programming. So we'll see about that in a bit. So I'll just go ahead and comment out all of these lines so that we really use examples to illustrate what we mean.
For example, you want to store the value 5 on the computer memory. Now the first question you want to ask yourself is, what data type is the number 5? And we've looked at 4 fundamental data types already. We have the Boolean types, we have the floating point, we have the numerical integer types, and we have the character types. Now we want to store a value of 5 on the computer memory. And from the data that we want to store, we know that 5 is an integer. So we proceeded with an int, with the int keyword over here. Now, the next thing we want to do is to give this particular value a name, so that anytime we want to work with it, then we use that name. So the name we want to give it is, let's say, num1. And so we use this equal sign to assign the value of 5 to num1. Now the last thing we want to do is to end this with a semicolon. Great. So let's go over this syntax again. We want to store the value 5 on the computer memory. 5 is an integer, so we use the int keyword. Now we give this name to this value, so that anytime we want to work with this particular value, we just use the name and not the value itself. So we have int num1 is equal to 5. The num1 over here is what we call a variable. Great. So then we come down here and let's say that we want to print out num1. So we just use the name num1 instead of writing 5 explicitly. So when we run this should print out 5 on the screen, because 5 is assigned to the name num1. Great. Now we can see 5 displayed over here. So we can conclude that the value 5 was stored against the name num1 on the computer memory. Great. Let's create a second variable. And in this case, we'll use the float keyword, because we want to store a value which is a decimal. And we want to call this particular value num2. And we are assigning the value 8.9 to that particular value. Great. Now we run this and we only have the value 5 displayed. Why? Because we did not ask the computer to print the num2 on the screen. What we only did was to create space on the computer memory to store this value. So that value is still stored on the computer memory, but then we have not asked to work with it. So if we want to work with it, we can say that the computer should add num1 plus num2. So now we want to work with num2, so the computer should do this. Let's run this. Again, we have just 5 displayed. Why? Because we only added these values. We added num1 to num2, but then we did not ask to work with it again. We did not ask it to be displayed on the screen. Even though we worked with it, we did not ask it to be displayed on the screen. So what we can do over here to display it is to use the cout and then num1 plus num2 to display that result. Now we will want to come over here to include an endl so that these lines don't crash. So we run this, and now we have 13.9 as the value of num1 plus num2, and then 5 as this initial value over here. So now if we did not include the endl over here, this would have been joined. It wouldn't have skipped to the second line. So that's why we quickly added the endl over there. Now the next thing we want to do is to store this value that will be returned in a variable. So let's create a variable to store that. So let's just say the variable is called int result, or let's say int answer. Int answer is equal to num1 plus num2. So we are adding num1 and num2, and we are storing that result in a variable called answer. So then we would come over here and then print out answer instead of num1 and num2. Great. So then we run this, and what we have is 13 and not 13.9. Why is that so? Now the first printing returned the value 5, that's num1, and the second cout over here is returning answer, and that's num1 plus num2, and we are expecting 13.9, but then it returned 13. Why? In mathematics, 13.9 would be, let's say, mostly rounded up to 14, but in this case we have looked at a data type called integers, and for integers they can only be whole numbers. So instead of 13.9, it returned 13 because that is the whole number that the number is made up of. So let's say that it's 13.9, 13.9999, whatever, it's still going to return 13. So let's say the next, the highest least number or whatever. So I don't know if you get that. So integers will always return a whole number and not a decimal. So if we want this to be decimated, then we would want to use the float keyword over here instead of the integer. So then when we run this, now we have 13.9. Great. So the keyword you use over here is very important because that determines it should be in relation to your data type that you are storing. So we have created a variable called answer, and the answer, is it going to store an integer or a float? Depending on that data type over here, then the data over here should correspond to that. So if it's an integer over here, then the data type should also be an integer, and that's why an integer is returned. In most cases, in some cases, that bugs get into code. Let's say you write a function and you make a computation and you are expecting a decimal, but then the function is returning a whole number, and you're wondering what is happening because you defined your function using an int. We'll talk about that when we get to functions if you don't get what I'm saying. Great. So now we have variables that we have created and we know how to store those values. Now let's quickly look at, so we've looked at floating points and we've looked at integers. Now let's quickly look at Boolean values. So let's say I want to store a value bool, and let's say bool a is equal to true. Now this does not need quotation marks. It doesn't need single or double quotation marks. This is a keyword on its own. The computer understands it, and you can see that the color changed as we input it, as we typed it out. So bool a is equal to true, and then so this is just a basic syntax that I want to just introduce you guys to, but then they are really useful in binary cases, whether the value is true or false when you're writing functions. But in this time around, we're not going to get into that. We just want to get the basics of it. Great. So we have created a variable called a, and we are storing a value true against it, and a second variable called b, and we are storing a value false against it. Now these values are Boolean types. That's why we use the bool keyword over here. So to work with these values, let's just say we want to print them. Let's just say we want to print them for the meantime. So print a, and then we use an endl to make it get to the next line, and then we print out B, and then with an ENDL to end it. Great. Now we might want to add an ENDL here so that it doesn't clash with, so that this line doesn't merge with this line over here. Great. So we run this to see the output. And now we have 1 and 0 over here. So the true is 1 and the B is 0. To make this clearer, let's put a string over here. We say A is equal to that, and then with a new line, and what we want to have here is B is equal to that. We'll look at strings into details later. I just use this because we know the hello world program. So, and hello world is contained in double quotation marks to print a string. So over here, this will just print out A is equal to true, and then B is equal to B. So let's run this to see the output. Now we have A equal 1 and B equals 0. Great. So true is 1 in programming and false takes a value of 0. Great. We could have also output a sentence over here that, let's say, cout. We could have output the sum of what is it? The sum of num1 and, let me just make these things so that you see. So the sum of num1 and num2 is, and this should be a string, so is answer. Great. So now we want to have an ENDL over here, and then we want to clear out all this because we do not want it to be printed. Great. So then we want to run this to see what the output is going to be. We have the sum of num1 and num2 is that, right? So then we have the sum of 5 and 8.9 is 13.9. But you can see that these things are joined. So what we can do over here is to, if we put spacing over here, it's not really going to work. Let's put the spacing there over there to see if it's really going to have any effect. So we run this, and let's see if the output, so we have to close this before we can get any new output. So as you can see, the changes were not affected. So putting spaces over here does not really have any impact. So where do we have to put the spacing? So I'll just go ahead and delete all of these spaces that I put there earlier. So we have to put the spacing over here. So when you put the spacing over here, the space would be printed as a string. So that is the idea over there. The space will be printed as a string as such. So let's run this now, and I hope that it's going to appear readable. Great. Now we have the sum of 5 and 8.9 is 13.9, and we can read it easily and all of that. Now let's say that you want to change num1 to, let's say, 10. So all we have to do is to come over here and put a 10 over there, and then we want to make num2, let's say, 60. And when we run this, wherever num1 is, then 10 will be put in place over there, and so the program is going to run smoothly. So imagine that you have tons of lines of code, and if you had not used variables and you were using 10 and 60, you were using the hard-coded values, you would have to go through the entire code to make those changes. But with using variables, you can just change the value of the variable, and wherever the variable appears, then the changes would be effected. We'll see their usage in strings. So let's run this and let's see whether the changes have been effected. So we expect the sum of 10. Now we have the sum of 10 and 60 is 70. Great. So the changes have taken effect. Now the next thing we want to quickly look at is what we call characters. So to create a character variable, all you have to do is to use the char keyword, and then after that the variable, the name of your variable. So let's call this alphabet, and we are storing in a character of y in there. So if you want to use the value y, then you can go ahead and use it in this case, we just want to print it out. So we're just printing alphabet, and it's going to print out the value y. Alphabet. Alphabet. Great. So let's quickly run this and let's see what the output is going to be. So now we have y output over there as well.
Right, so right now I want to introduce the concept of variables. But before then, I would like you guys to play a game mentally. So I'd like you to pick a number, just pick any number. And then the second step is to pick a second number. Right, so you have two numbers in your brain right now. Then I want you to add one to the first number. Right, and then the fourth step is I want you to subtract the second number from the first. Right, so this is a mental exercise, and you could have lost track of the steps and the procedure as I increased the number of steps. Now the computer can really do this very fast and within a short period of time, and this is where the concept of variables come in. So let's define what a variable is. A variable is a portion of memory to store a value. So you have a portion of memory allocated to store a value. Now we'll see what we mean by that in a bit. Now, how do we declare variables? Now, this is the procedure to declare variables. You have to, first of all, declare the data type, which we have talked about over here. So these are the data types, fundamental data types: character, integers, float, and bool. So you have to, first of all, declare the data type. Then after that, the identifier, that's the name you want to call the variable by. Then after that, you equate it to the value you want to store. Right, so what do I mean by that? Let's say I want to store a number 5. So 5 is the number I want to store. And 5 is what kind of data? It's an integer because 5 is a whole number. Okay, so we call this by using the keyword int. Right, and after that, that is the data type. The next step is to give it an identifier. Now, the identifier I want to give it is num1. Right, and then we want to assign it to the value 5, and then don't forget the semicolon. Right, so this is what we call a variable. The variable is called num1 because that is the identifier, and the value it is storing is 5, which is what? An integer. So that is how to declare variables. Now that's the first step I want to use. I've picked a number num1, which is 5, and I want to pick the second number. So the second number I want to pick is, let's use a float. It's going to be of type float, and let's call it num2, and let's assign it to 7.8 with a semicolon. Right, and the third step is to add 1 to the first number. So let's add 1 to our first number. So num1 is equal to num1 plus 1. Right, don't kind of get confused with this line of code. All I simply did was I updated this value. I then equated it to num1 plus 1. So whatever num1 was, add 1 to it and then just keep it as num1. Right, so I added 1 to my first number and then subtract the second from the first. So as I have added 1 to the first number, my first number is now my first number that I had plus 1. So that is now my first number. So let's subtract the second from the first. So it's going to be num1 minus num2, right? With a semicolon. Now, this result, as you might have guessed, is going to be a decimal, right? And decimals in C++ are denoted by what we call float. That's the data type. Good. Now, this is our data type. This is our data type that our result is going to be, and this is what our result is going to compute to. Now, what do we want to call this value that we would have? Let's just go ahead and call it result, or we could have called it answer or anything that we want. So answer, and then we assign it to this computation. Right, so then let's go ahead and run this and then print out our answer to see what we really have. So if you want to print out something, you use the cout keyword with two less than signs and then answer. Right, and then with two less than signs and ENDL with a semicolon. Good. So let's run this code and see what we will have. For me, I will use the shortcut Shift plus B right? So we have 1 negative 1.8 as our answer. And you can use a calculator or you can just compute it um, like that to kind of check. Because let's see, number 1 was 5, 5 plus 1 is 6, and then 6 minus 7.8 obviously is negative 1.8. So our answer is right. So that's how to declare variables, and I just illustrated it with the example that I took you guys through. Okay, so now let's look at what are called identifiers. Now, over here, num1 is what we call an identifier, num2 is an identifier, and answer as well is an identifier. Now, identifier is simply a name that is given to a variable in order to be able to identify it. Good. And it's good practice to give an identifier that is relatable to the data. So over here I gave the name answer, the identifier answer to the result, because it is the answer to a computation. We could have said a result, which is even far better because it's a result of a computation. But let's say that we rename this as anything like school. Even though it's possible, we can give this as school. Now, what does school have in relation to num1 minus num2? Even though we can print out the school, shift B, it returns the same value, but then it doesn't really have any relationship with our data. So it's always good to give it an identifier that is relatable. So let's go ahead and give it result. Yeah, I think that's much better. Result. And over here as well, we rename it to result. Right. So now the second thing to remember is that identifiers have alphabets, numbers, and underscores. So we can name them using alphabets, which you have done over here. We can name them using numbers and with underscores. So I could have named this as num1 like that. And then I come down and rename this as num2 like that. And then over here, I update it to num1 like that. And then, yeah, and we run this, shift B, and okay, so over here, okay, I should update this one as well, right? And then update this one as well so that everything is uniform. I would update this one as well, right? So shift B, and we have the same result over here. We press any key to continue and it closes that for us. Good. So now these identifiers can't have space, they can't have symbols, and they can't have quotation marks. So let's say that I leave a space here like this, right? Let's run this, and obviously it's not going to work. So let's update all of these and put in spaces in there to see what will happen. And when we run the shift B, we get that over here it says error, expected initializer before numeric constant. Yeah, so over here this is being read as a constant. We'll talk about constants in future videos. So over here it's identified by the computer as a constant, so you can't have this. It would bring up errors. So I'll just go ahead and undo all these steps, right? So you can have spaces, you can't have symbols, and you can't have quotation marks. You can try out those yourself. Now we can't also begin with a number, right? So if we begin with a number here, let's say 9 num, you can try out all of those ones as well to see the effect, but it's going to throw out an error. Yeah, so we can't have begin with a number as well, and we can begin with an underscore, but it's not good practice because these identifiers are mostly reserved for special purposes in C++, even though you can begin with it, right? So we cannot also use a keyword. So let's say that we can't say keywords are, for example, int, float, and then we can have return, the return keyword that is used in the main function. We can't use return as well. So let's say that even though this computation is going to return a value, we can't say return because that is already a keyword. And you see that as we wrote the return, it was bolded. That means that this has already been taken. It's a keyword in the computer for a specific purpose. So what we can do here is just clear this out and restore it to result. so we don't have any problem. So remember, you should not use keywords. And as we continue, you see more of keywords. Examples of keywords are return, false, float, and all of those. And now identifiers are case sensitive. So over here, I can say num1 and I come here and then I write capital N, right? This one is totally different from this one because they are case sensitive. Let's go ahead and run this to see what's going to happen. And you can see the arrow thrown over here, this red column over here. It says num1 was not declared in the scope. Did you mean num1? Yes, that's what I meant. So they are case sensitive. Take note of that. It's usually the source of many bugs and in codes. So we've looked at identifiers and what not to do. And now let's look at how to initialize variables, right? So the first type is the C-like initialization. What do I mean by that? So in this type of initialization, we can have the format is a type, the type you write out the type, then the identifier, and then the initial value. And that's what we've been doing so far. So we write out the type, and the type is int. We want to store an integer, and the identifier is, let's say, num4, right? And then the initial value, let's say the initial value is 8, right? So this is what we call a C-like initialization. Good. And now the second type is what we call constructor initialization. And the format, this is the syntax. You have to use the type, which is going to be an integer, and then, or let's use a different type, let's say character, CAR. We're storing a character, and then the identifier is going to be, let's say, letter. This is the letter, and then we put in brackets and store the initial value, let's say T, anything, with a semicolon at the end. Don't forget that. So this is what we call constructor initialization. We can also have an example like float, and then we can have num6, and then we can have this, let's say 7.8, or let's put a negative in there, right? So this is it, another form of initialization. You can use this form or you can use this form, right? So we go to the third one, which is uniform initialization. Now it's almost like the constructor initialization, just that we use curly brackets in here. So we can say float, num7, and then we use curly brackets in place, negative 7.8 is the same thing as this, sorry, over here. So what this line of code does is the same thing this one does, just that we are using a different style. And it is the same thing that this one does as well, just that we want to use different styles. So that's what we call initialization of variables over there. Now I want to talk about okay, so that's all about the initialization. So let me quickly add this before we move on to introduction to strings. Now let's say that I was declaring integer here. Let's say that I wanted this to be an integer as well, right? And let's say that the result is to be an integer as well, right? So let's go ahead and update this value so that it becomes an integer. So all of this is in line. So now you can see that I have int, int, int. Now what I could have done is I could have just done all this in one line of code. So I could have done int num1, comma, num2, num3 with a semicolon. Oh, sorry, there's no num3. So we have result, because result is also an integer, right? So we could have done this, right? And then we come down and then say num1 is equal to, was it, yeah, 5 semicolon, then num2 is equal to 7, and then num num1 num1 plus num plus 1, right? And then we have result result equals num1 minus num2. Right, so we go ahead and comment out all of these. So we've commented out all of these, and then we want to run these lines of code to see what is the result, what the result is going to be. So I'll go ahead and run the shift plus B, and an error is thrown over here. Sorry, I have to include a semicolon over there. Shift B, and now we have -2 as the output. Let's quickly see if that's true. So our num1 was 5, right? And then we came down here, 5 plus 1 is 6. So num1 has been updated to 6. So 6 minus 7 is -1. So what I can do over here is I should update this num1 to be num1 is equal to num1 plus 1, right? So we go ahead and run this to see what the result is going to be. And now we have -1 as expected, right? So that's what should have been done. Now what we did earlier is what we call a semantic error. The error was not from the computer, but it's error from understanding. So we'll talk about errors in future videos, but this is just a mishap that brought that up. So this is how to go about it. If you need to initialize several variables with the same data type, you can do it in one line. Good. So now let's go ahead and then make some variables as well, like you might be wondering why these values did not appear, because we just declared them. We just stored them in the memory. So you know what a variable is now. It's portion of memory that has been allocated to store a value. So we just allocated memory to store these values. But right now we've not called them out to do anything. So if we call this number out, let's say call this to say cout, and then we have num6. So this will just print it out. That's what it will just do. So let's run this. Shift B. Right, so we have -7.8 over here. So after declaring a variable, it doesn't appear on the screen unless you print it out. Or after you declare it and it's in the memory, it doesn't do anything until you call it to do something. And as we get more and more into the tutorial, you'll get to know what I mean by that. Okay, so that was the data types and variables. Now let me just do a quick introduction to strings. So now what is a string? A string is simply a compound data type, and it's made up of the other fundamental data types. Now before I can use this data type, I have to include this line. Copy. I have to include it up here before I can use that data type. So I'll come over here and paste it. So this is the line you should include before you can use this data type. Remember that. So it's hashtag include string. So we have included it, and we'll go ahead and then declare a variable of this particular data type. So let's say that our first variable is going to be a string. So that is the data type, right? So you first of all declare the data type, and then you give it a name, which is going to be say hello, right? And what value is it going to store? It's going to store hello world. We have our cute friend over there again, hello world. Okay, so let me just add this endl. Now what I did over here was, this is a variable called say hello, and it's of data type string, right? And the value I'm storing in there is hello world. As you might have seen, hello world is made up of characters: character H, character E, character L, and so on and so forth. And this data type is stored in two quotation marks. Note the difference. Characters are stored in just a single quotation mark over here, just a single quotation mark, just like there, and then over here, just a single quotation mark. But then strings are stored in double quotation marks, right? So it's a compound data type because it is made up of several other fundamental data types. So I could have said, hello world, I am 8 today, right? So you know that 8 is an integer, but over here I have put it with a string. So let's go ahead and then print out this to see what the output is going to be. So cout, then we are printing out say hello, right? Then we end line to have space if we add another line. So we go ahead and run this shift B, and we have an error over here. So let's see what the problem is. Sorry, I added this over here. I shouldn't have. Right, so that is the error. So we have corrected it and we are ready to go. So shift B. And now we have hello world, I am 8 today. Right. So that is how to declare variables to store strings. And you know strings are compound data types. Now let's go ahead and then print out this character that we have earlier. And the character was letter, right? You remember, right? ENDL. We stored it as a letter over here. So this is the variable and it's storing a letter T, right? So let's go ahead and run this shift B, and we have T displayed over here, right? Now before we end this video, let me just make this quick comment. Now over here we could have used this format, car letter is equal to T, just like that, and it will do the same thing like this one did. The only difference is that this is a different style of doing it. So the uniform initialization, the constructor initialization, and the C-like initialization do the same thing, just that they offer versatility, like different ways of doing the same thing. Yeah, and I wanted to let you guys know that before you see this somewhere and you would not understand it. So please take note of that. Now, let's illustrate this concept using the various initialization types. Okay, so let me go ahead and do that. So we're going to create 3 variables to store 3 strings. So the first one is going to be, let's say, string greetings. Greetings, this is what we want to call it. And then we just want to store in hi. That's it. We've created a first variable to store hi. Now the second way is we can say string, let's call it greetings greetings 1. And what we want to do over here is to store in hey there, right, with a semicolon. Don't forget that. And this third way of doing it is to use the one with the curly bracket, so greetings 2. And we would have hello buddy, right? Good. So we have created 3 variables with it using the 3 initialization types. So let's go ahead and print out all of these. Cout greetings endl, right? And then cout greetings 2, greetings 1, sorry, with an endl, and then cout greetings 2 endl, right? So let's go ahead and run this to see what the output is going to be. And I have an error over here. Redeclaration of character letter. Okay, so the error here is that I declared this variable twice, so I can't use the same name 2 times. So I should just let me change this to a capital letter, right? So that we have that difference. So shift B again, and now we have hi, hello, hey there, and hello, buddy. So that is declaring string variables using the three initialization types. Now let's look at the last thing, which was run this line to explain point. Okay, so now what I want to explain right now is when I print out cout, let's say cout greetings, what do you think the output is going to be? Over here, greetings is a variable which stores a value high, and we printed out, we called greetings over here, and it printed high on the screen when we ran it. Now I am putting this variable in double quotation marks. What do you think is going to happen? So the last thing we did was we called out greetings, and you see over here that greetings was explicitly printed on the screen, even though it's a variable which stores high. So what we can learn from this is that when you put anything in strings, when you put anything in double quotation marks, it makes it a string. Even though greetings was a variable, if you put it in quotation marks, it will be interpreted as a string, just like hello buddy, just like hey there, just like hi, and just like hello world. Yeah, so that will be it for this video on variables and data types in C++.